Good afternoon. So I've been working on dermatology AI for the last 10 years. And before that, I was an investment banker in healthcare for Barclays, Los Angeles, New York, and also a trained electrical and computer engineer. And many of the concepts that I'm going to go through today, as far as problems, challenges, ideas, solutions, we've actually incorporated into our solutions. So less on the theoretical would be nice, as much as it is actually practically has been implemented. So I wanted to, before I start, kind of categorize the three frontiers: telederm, digital derm, and AI. The purpose of this is not to actually delineate perfectly, because there's a lot of overlap, but more the sort of conclusion at the bottom, which is the major kind of point of telederm, digital derm, and AI, which is access in telederm, efficiency, at least from my perspective, and for AI, effectiveness. Now, I've highlighted the education, upskilling, and empowering because that's a major theme for this panel. But what's happened in the last 2 years with the advent of generative AI is that AI has also driven efficiency in addition to effectiveness. Again, the main reason that I want to point out these things on the slide is not the actual nuances, but the fact that there's a concept in healthcare called the iron triangle, which is that there is a difficulty in advancing all three corners of the iron triangle, which without sacrificing one corner, with those three corners being access, efficiency, and effectiveness. And the ultimate goal to build the ultimate derm system is to elevate all three without sacrificing one corner of the triangle. And so that's a major theme in what we've sought out to do. This talk I'll cover past AI challenges and learnings, industry implementations and applications, and perspectives on the next 10 years of AI. So just to go back a little bit, where we started with CNNs and deep learning, it all started with a cat who Bell and Wiesel in 1959 inserted electrodes and presented stimuli and saw and kind of monitored what happened within the visual cortex. And we ended up with a mapping of the hierarchy of feature detectors. In 2012, I think most people who follow the space know that AlexNet achieved state of the art, and this was kind of an inflection point as far as the classification potential of AI. As far as the overall catalysts and inflection, it was due to frameworks and algorithms, large data sets, and GPUs. Now, GPUs were around for a while. Most people know them as video gaming cards. And the difference between GPUs and CPUs is that GPUs, maybe an analogy is GPUs are large trucks, CPUs are Ferraris. Ferraris can move small amounts of data very quickly. GPUs are better for large chunks, which is what a lot of the large data sets and the algorithm training is entail. I thought I'd go over kind of the last 10 years of major AI challenges, and the major challenge that was faced, at least from my perspective, each year. 2015, to start there, data. Lack of diversity and a tremendous amount of sensitivities. And those sensitivities exist today, but my point is that you couldn't access data because people were very protective and there just wasn't any open source or openly available. 2016, let's assume that the data problem was partially solved. You then got into a problem of domain transference and adaptation. You would train your AI model on a certain amount of data, but it would collapse very quickly once you removed it and applied it to a new domain or a new source of input of images. 2017, again, this is maybe specific for my eyes, but ontologies. How are you actually structuring the training of your algorithms? The medical hierarchy and the relationships between the children and the parents, and if you had sufficient data to delineate that granularity to the point where it actually has utility to the user. 2018, robustness and consistency, always a problem with AI. You train on a certain amount of data, take it out of its environment, collapses. So even if it does perform so well, you have a decrease in performance. 2019, incorporating metadata, going beyond the images. This is something obviously that Visual DX and others does very well, which is figuring out how to actually augment and support the pure visual side of diagnostics. 2020, optimizing efficacy. This is a concept that still persists, which is the overconfidence and the misleading confidence of AI and how to optimize for that. 2021, integrations efficiencies. It's not sufficient just to create a tool that has tremendous diagnostic efficacy. You have to spoon feed it, you have to make it very easy, you have to make it synchronized, and you have to make it integrated with existing systems. So that was another challenge. Once you built a magical system, it was another problem to get stakeholders to take it on and integrate it. How and what to output, clinicians versus patients. What do you actually, once you build the magical system, once you have the integrations, what do you actually want to show? And then geographies, fine-tuning for specific locations and their data, which is an ongoing problem. Some of the key learnings: AI is complex and fragile, has false levels of confidence. This is a dangerous one. And this is kind of in the same sphere as hallucinations and confabulations and just a general real danger with AI, and will always be a real danger with AI. And the second part of that is they lack of awareness to the significance or the context of that case. So if, for example, a doctor is identifying or diagnosing a mole, they know that there's a high risk with the context situation. The AI does not have that context. So they don't have the ability to give weighting to the actual situation of their decision. AI tools need careful oversight, cannot be taken for obvious, and maybe on a more positive note, it is very powerful. Very, very powerful, especially in recent days as a generative and augmented tool. I thought I'd give a case study on something we've done, which got a lot of attention in our publication. Not the most citations, but definitely was the most inbounds we got of people trying to figure out how we did it or how they can figure out from around the world, which is creating synthetic data from a text prompt. The purpose of this, albeit obvious, one, to round out and improve your data set. There's actually a second benefit, which was far more significant, which is how to circumvent traditional data sensitivities and privacies. If you want to access someone's data, the hoops and the walls that you have to go to are significant. Is there a way to cut the corner and go around it? And there is a way. So just to go one by one here, addressing like real-world data, advance the techniques of text-to-image models, determine impact. And then this fourth point is the one that I just referenced, which is data sharing without infringing on confidentiality or custodianship issues. How do you access and leverage a healthcare organization's data without going through all the bureaucracy and red tape that every one of these healthcare organizations? How do you do that? And mechanically, the way you do that is by using generative AI in combination with a concept that is in AI called transfer learning, which is essentially taking the vector features, learning and training onto a model without actually moving the data, taking that vector learning out and either combining it with your own models or using it to actually generate synthetic data based on that data. So as a sort of mirror, if you will, but a mirror with slight differences. So it isn't new. This is an example of synthetic images that we created. We showed about 100 images to 25 dermatologists. 24 of them couldn't distinguish between them and original images. Just a quick kind of snap of what we're doing actually globally. We're mostly in Europe. So we're in Hungary. We partnered with the government and provided the service as a free service for the entire population. And this is let's call it a Telederm plus AI platform. So people can submit, store and forward, they can submit, the AI does diagnostics, sends it to a dermatologist. Slovakia partnered with the #1 insurance company, and they made it a requirement that their policyholder base has to use this as a first layer prior to going to see a derm. Obviously, in the insurance game, cost cutting is the primary business model purpose, and that's how they do it. And then in Spain, partnering with clinics. So in Hungary, the reason why I focus on Hungary is because it was free access for the entire country. And when you have free access to a tool, you get the entire population from all spectrums of profiles submitting cases. And there's tremendous learnings of that. And then add to that, we switched the free pilot to a paid service. And so you've got a really interesting kind of dichotomy of data in terms of how does that actually affect the patient submission behavior and the patient profiles. I'm not going to go through it, but just a general thing. We got 30,000 submissions, good responses. The entire country we service with less than 10 dermatologists on a part-time basis. So there was a tremendous efficiency that the platform accelerated, and the AI was also proved to be very potent. Now, this is some of the takeaways. So what we see on this table here is that we looked at the top 5 most common occurring conditions across the country. Across the country, we had submissions from up to the age of 101. So our oldest user was 101. And so you had, which makes sense intuitively, you had a lot of people submit common moles. It's a free service, they could just spam it. And on the paid service, you had contact dermatitis come. And then Seb K and the others following that. Another major takeaway is the number of referrals on a free service basis to a paid service. Referrals meaning, hey, you actually have to come in and see us. So as a free service, 60% of cases were referred to in-person clinics. And that was driven, in fairness, partly because the clinicians were just getting used to the platform and didn't have perhaps as much comfort or confidence in it. But that switched to 30% on paid service for a variety of reasons. Two of those reasons is one, you had a much higher quality of input because people were paying for it. They weren't just spamming low quality images. You had a higher quality image being submitted. You had people who were much more serious about what they were submitting. And you had the clinicians who were also more comfortable and more confident with using the system. One of my favorite observations from this experiment is that more than 36% or more than 35% was over the age of 50. This was still to this day a very shocking thing to me. I still can't believe that that was the result because intuitively we know, elderly don't use technology. I mean, that is the common theory. But again, to have more than 35% come from above the age of 50 is still an incredibly surprising result. And nothing groundbreaking here. Fitzpatrick between 1 and 3, it's a European country. So just to summarize feedback from clinicians and patients in terms of what they liked, what they didn't like. On the patient side, on the patient side, they liked the speed, the ease of it, the sophistication. Clinicians liked the gamification of it. This is something that was mentioned earlier about the importance of the psychological sustenance of clinicians and the burnout. This was something that was tremendously enjoyed from the clinician side. I'm going to skip through here just to get, because I'm running out of time. So if I were to summarize the old and new frontiers in AI, we have the imaging AI, which you could say was used for diagnostics, for triaging, and for image capture quality. You have the visual generative AI, which I touched on in terms of the case that we used for image generation and image manipulation augmentation. And you have the more recent wave, which is NLP and LLM models, which you could argue is used for a variety of things, but customer support, educational support, and clinical support amongst them. This is my last slide. So this is kind of our perspective on the next, let's call it 9, 10 years. What are the next advancements? I believe what's coming up next is significant evolution of the generative and augmentative AI, which is obviously LLMs, but both on the NLP side and the visual side. That's happening at a very rapid pace. Perhaps over the next 2 to 3 years, advanced model merging and multimodals, stacking several models together, models talking to each other. We actually already have 2 or 3 AIs talking to each other within our system, which is a little bit creepy, but it is what it is. After that, we have longitudinal case and patient outcome models. This is something that actually Art just touched on, which is how do you actually get to the next level of efficacy, and it's undoubtedly incorporating this into the process as far as personalization and, again, the longitudinal data. This is a more debatable one, but the reason why I have it so far out is because of the hardware component and how much time and money it'll take to commoditize access to 3D scanning and AI en masse. But there's no question that once it gets to that point, that's going to be an incredibly effective system. And by commoditization, I mean the easy access, cost, every office having it, and the AI to pair with that. The last point, and this is the end of the presentation, AGI. I'm not sure if many people have heard of AGI, but it is the next major wave that's going to happen in the next 5 years. It's a wave that's not a singular innovation, but it's actually going to ride and raise up essentially everything that's come before it. And it's something that is going to be operating without context, without catalysts, right? So right now we need to trigger an AI model to, hey, do this. Hey, here's context. Here's AGI is now getting into the sphere of it's doing it on its own. You're giving it an identity and you're saying, you are my assistant. Go seek out how to optimize and do it individually without without my catalyzation of it. And I mean, this is, I think, what some people are worried about in terms of sentience and it going and wiping us out. But, what in the worst case, it's an early eternal vacation for us. Thank you.